Welcome back to our system design series. Today we are diving into a powerful technique for scaling databases called database sharding. Sharding is a strategy used to distribute data across multiple servers, enabling systems to scale horizontally to handle more traffic and larger datasets efficiency. So, understanding sharding is critical and crucial for designing systems that need to manage massive amounts of data while maintaining performance. Let's take an example of how sharding works. So let's just make a small system. We have a client, and this client sends requests to the server, and the server will send the read and write request to the DB. Let's say that we have one big DB server that have all the data in it. Basically, sharding it's all about that breaking this big database server into smaller, more manageable pieces called shards. By this way, by distributing the data across different servers, this will help us to store more data, and also it helps in balancing the load. So, what is exactly database sharding? In simple terms, sharding is a process of breaking up a large database into smaller, more manageable pieces called shards. Each shard contains a subset of the data, and together all the shards from the complete datasets. By spreading the data across multiple servers, sharding helps distribute the load and reduce the amount of data each server needs to handle, which in turn improves performance and scalability. Think of sharding like dividing a large library into different sections. And instead of having all the books in one massive room, you organize them by categorize into smaller rooms. Each room represent a shard, and finding a specific book becomes faster because you are only searching within a smaller collection of books rather than an entire library. So, as I said, there are several common ways to determine how data is split in the shard. So, right now we break this massive database into smaller shards. Like, let's say that we have shard 1 and shard 2, or maybe shard A and shard B and shard 3. We have three shards right now. Let's understand how these shards are created, or how do we handle sharding. So, the first thing, there is what we call a range or a range sharding. The range sharding, in range sharding, data is divided based on range values. For example, if you have a data set of customer orders, you might shard by order ID, which with each shard to contain a specific range of IDs. This approach is easy to implement and understand, but it can lead to hotspots where one shard becomes overloaded if the data is not evenly distributed. The second way to handle shard is the hash, like using hash function, hash sharding. So in hash sharding, a hash function is used to determine which shard each piece of data belongs to. This helps distribute data more evenly and avoids hotspots, but it can make range queries more challenging because data is scattered across shards in a less predictable way. And next we have uh, a geographic shard. Geographic. For example, with users spread across different regions, like geographic sharding can be an effective strategy that is partitioned based on geographic locations, ensuring that users connect to shards closest to them. reducing latency and improving performance. This approach is often used in global applications where user proximity is important. So let's try to think about a real world example. So let's imagine that we are building a social media application with multiple clients, and we have like a lot of clients sending a request to our servers. And right now we need and they storing their data in our database, and we need to handle shards right now because one database cannot handle all the data of the clients. So one of the things that we could, as our user base grows, a single database might struggle to handle the volume of data and queries. By using sharding, we can split the user data into multiple shards based on user ID, for example, or so basically, we can like create like, let's say that we create like three shards, and each one has its own. Let's say that we have two shards, and no, let's make it three. Let's make it three. Three is better. We have three shards, so this is shard one, this is shard two, and this is shard three. And basically, shard one will handle the we will shard the data into based on the IDs. So IDs from 1 to 1 million will go to shard 1, and IDs from 1 million to 2 millions go to shard 2, and IDs from 2 million to 3 million go to shard 3, and so on. This way, each shard is responsible for only a subset of users, reducing the load on each individual server and enabling your system to handle more users effectively and efficiently. So, sharding brings significant benefits but also come with challenges. One of the main challenges is complexity because implementing sharding requires careful planning to ensure that data is distributed evenly and the system can locate data across multiple shards efficiently. So we there is rebalancing shards, because rebalancing shard can also be quite challenging. If one shard become too large, you may need to redistribute the data to maintain performance, which can be complex and time consuming process. Another challenging is the cross shard queries, like when data belongs in different shards needs to be accessed together. It can be more difficult to perform those operations efficiently. For example, if the user data is spread across multiple shards and you need to generate report that include all users, you will need to query multiple shards and aggregate the results, which can be slower than querying a single database. Despite these challenges, sharding is an incredibly powerful tool for scaling databases that need to handle high volume of data and traffic. It allows you to scale horizontally, adding more servers to handle more data rather than scaling vertically, which involves upgrading a single server. Horizontal scaling is often more cost effective and provides better redundancy and fault tolerance, as each shard is independent and issues with one shard doesn't affect the other one. So that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future videos.